An interesting application of recursion is sorting the data in a given array. This is known as MergeSort. MergeSort depends on merging the two arrays that are already ordered, and the resulting array of that merge is also an ordered array. So before we take a look at the recursive implementation of the MergeSort, let's take a look at how would we merge two arrays that are already ordered in an ascending form. Let's say we have two arrays. Array A has 4 elements, 23, 47, 81, and 95. Array B has 6 elements and they are already ordered as well. Our objective is to merge these two arrays so that our resulting array C, which is going to be 10 elements long, is also ordered. So how would we do it? The first step would be to compare the very first element in array A and very first element in array B. So index 0, compare those two, which one is smaller, we copy that into array C. So that is my first step. So compare 23 and 7, and since 7 is smaller, we copy 7 from array B into array C. Now the next element in array B is 14, and since 23 has not been copied over, it is still the first element in array. So I am going to compare 14 and 23. Since 14 is smaller, I'm gonna copy over 14 and move on to the next element, which is 39. Now I'm gonna compare 39 and 23. Since 23 is smaller, 23 gets copied over into the array C. Next, I'm gonna compare 39 and 47. Since 39 is smaller, 39 gets copied over into array C. Next, I'm gonna compare 47 and 55. So since 47 is smaller, 47 gets copied over into the array C. Next comparison will be between 55 and 81, and 55 gets copied over. 62 and 81, 62 gets copied over. 74 and 81, and 74 gets copied over. Since there are still elements left over in array A, I have to check all the way to the end of the array A, and any leftovers will be copied into array C. And there is a possibility that same thing can happen in array B. That means at the end I will have to check array B as well for any leftover items. Now our final array C is going to look like this, in which all the elements are copied from both array A and B, and they have been already sorted in the ascending order. Let's implement this method. I already have the two arrays set up in my MergeSort class with the data, and the method that we have to implement is merge. Static void merge. I am going to pass the two arrays to it, so int array A, int array B. The first thing I'm gonna do is create my array C, and the size of array C is going to be the sum of the sizes of array A and B. Then I'm gonna create a couple of variables that will be used to keep track of the progress as I am progressing through both arrays. So I have created 3 variables for that. Now I'm gonna loop through the two arrays. So while I is less than equal to a dot length minus 1 and j is less than equal to b dot length minus 1, I'm gonna copy over the data either from B or A into C. So C k plus plus is going to be equal to some condition over here. So data gets copied over either from A or B. Now what is this condition? This condition is going to be if A of I is less than B of j, then I copy the data from A. If A of I is not less than B of I, then I copy the data from B. Now remember that once we are done with this first iteration, I still have to make sure that there are no leftover items in either array A or B. So for that, I'm gonna set up another loop while I is less than equal to a dot length minus 1, c k plus plus is equal to a of I plus plus. And similarly, while j is less than equal to b dot length minus 1, c of k plus plus is going to be equal to b of j plus plus. And finally, I'll go ahead and print it out, but before that, I'm going to create a variable called n, and that is going to be my total loop count. So that is going to be my c dot length minus 1. Now my loop over here, so for int t is equal to 0, t less than equal to n, t plus plus, and all I'm gonna do over here is print out my C array. The next thing I need to do is uncomment merge over here and pass in array A and B. Now let's run it and make sure it works, and as you can see that my data is already in ascending order in my final array. Let's take a look at the recursive implementation of the merge sort. If I am given data in unordered form in an array, I can use this technique to sort it out. How would we do that? Well, I can split the array into half, ordered each half, and then merge them back using the method we just created. The question is, how would we order each half? I can split the half into further halves and then order those quartiles and merge them back into halves, then merge the each ordered halves and back to the original array. Now the question is, how would I order that each quartile? Well, I can split each quartile into halves. So you see where we are going with this. We are recursively splitting our array into half until we reach to an array that has only single element. That's when our recursive method will return with that value indicating that it is already sorted. Now we can start combining those broken up arrays back into original arrays. So in this particular case, our last element that will be returned to us is going to be 64. So I can combine 64 and 21 and I get my first quartile. Similarly, my 33 and 70 will be compared and ordered and I will get a quartile from that. Now these two will be merged together to give me an array of 4 elements. In the upper half of the array, same thing will happen. So I will get 2 elements from index 4 and 5 and 2 ordered elements from index 6 and 7. Now those 4 will be combined into upper half, and then finally we combine the lower half and upper half into our final array. Let's take a look at the merge sort applet. Initially, I am given an array of 12 elements and the values are unordered. As we progress through this applet, keep an eye down here, the messages that will be displayed. Now, to work through this merge sort recursive implementation, I need 3 variables, lower, upper, and middle. These will hold the indices of the array as I make the progress. So when I click the step first time, this is my initial call to the merge sort. I click again and my index 11 is assigned to upper. Essentially my whole array 0 to 11 is going to be worked on. I click again and I find the middle point of that, which is my index 5, and now I have split my array into half and I am going to start the lower half first. Click the step again and it tells me now it is going to call the merge sort again. So this is my second call to the merge sort. So I am already doing the recursion and now I am going to sort my lower half, which is indices 0 to 5. And as you can see now my upper becomes 5. Click the step again and I find my half, which is going to be 2. Now I am going to work on my lower half of this. So essentially I am working on my quartile of the whole array. And on the next step, you can see that my upper is assigned to 2. And now I will work on the 0 to 2. So this is my third call to the merge sort method. And I am going to step again, and that gives me the half of that quartile, which is midpoint is going to be index 1. And I step through again because now I am going to sort the lower half of this quartile. So step through again and my upper becomes 1, and step through again and another call to the merge sort method will be made so that I can work on the lower half of this 2 element array. So that gives me the midpoint of 0. I step again and my upper and lower are both 0. At this point, I cannot divide my array any further. That means that the value of this point is going to be returned. This is my base case for my recursion. So the value of index 0 is going to be returned. Now remember that this was my lower half of a 2-element array. So once I return once I exit from the merge sort 0, 0, next I look at the upper half of that 2-element array, which is my upper half of 1, 1. And I return that value, and then I am going to merge these two together. And remember that the merge method that we just implemented, that will automatically order it, and I will have my two elements in proper order. Now this is the lower half of my quartile. So once I am done with this, I will move into my upper half. So now I am going to move into my upper half. So my upper half, I'm going to do the same thing. So we keep this doing until we have sorted each half, merging them together, sort the next half, merge them together, and so on until we reach to the very end. I highly encourage you that you play with this applet for a little while. Let's implement this recursive merge sort method. The first thing I'm going to do is I'm going to create an array AB, and that array will hold the values from the two arrays that we had in merge sort. Next, I have to implement a method called merge sort. So how would that method look like? Static void merge sort. Since all this merge sort method is doing is splitting array into half until we reach to the minimum, all I need here is my lower bound of the array and my upper bound of the array. If my lower bound equals to upper bound, that means I have reached to the final single element, and all I have to do is return from here. This is my base condition for recursion. Else, I am going to find the midpoint by summing up my lower bound and upper bound and dividing it by 2. And then I'm gonna call merge sort again with lower bound and my middle as the upper bound for my lower half, and merge sort my m plus 1 middle plus 1 and upper bound as for my upper half. And finally I'm gonna call the method merge to merge the two halves that will be sorted by the two merge sort methods. Now we'll have to modify the merge method for this particular implementation. So the first thing I'm going to do here is I'm going to change this into int parameter, int lower bound and int upper bound. Now I will have to make few more changes. So array C is now going to be upper bound plus 1 length because I want to fit everything in. Also, I need to find out my middle point here. So that is again going to be LB plus UB divided by 2. Now, int I is keeping track of my lower half. So it will always start at lower bound, and int J is keeping track of my upper half. So it will always start at M plus 1. And in this first while loop, the upper bound or the maximum value in my lower half is going to be M. And in case of upper half, my maximum value of the index is going to be upper bound. Now I will need to change this array into array AB since we are working only in a single array. I forgot to make this variable static. So here we go. Now in my second while loop, again, I need to put here my upper bound, change the array to AB, make this variable to upper bound as well, and change this to AB as well. And this here, now total number of items that I have to traverse through is ub minus lb. And instead of just printing out onto the screen, all I need to do is copy it back into my array AB. And this is so that I can start again from the beginning. So array AB lower bound plus t is going to be equal to ct. Now I'm gonna go ahead and uncomment this merge method here, and I'm gonna pass in my two parameter values. Also, I need to go in and modify my main method. So the merge sort will be called. For that, I need to create the upper bound here. Int n is going to be equal to ab dot length minus 1, and merge sort will be called with the initial lower bound of 0 and upper bound of n, which is my whole array. Finally, I need to print int I is equal to 0, I less than equals to n, I plus plus, and system dot out dot print line and ab of I. Let's run this and see if it works. And it seems it worked.